Hello, and welcome to the Queensland Ambulance Service LiveMUM training course. This course is intended to provide three main components. 1. A high-level overview of LiveMUM features and functionality. 2. A review of the specific configurations that have been built to support the QAS's coverage objectives. And finally, a short introduction to the main LiveMUM interactions, including viewing and committing recommended move-ups. LiveMUM stands for Live Move Up Module. It is a real-time application that continuously monitors coverage levels and provides efficient, smart move-up recommendations when coverage levels decrease. LiveMUM listens to CAD information in real time, updating coverage calculations based on changes in unit activity. For instance, when an ambulance clears the hospital or is assigned to a new incident, LiveMUM immediately recalculates whether coverage levels are still optimal. In addition to real-time information, LiveMUM is built and configured based on a wide variety of historic data points. This includes ambulance travel times, the number of incidents that have occurred by time of day and day of week, how long ambulances were typically committed on incidents, how long they waited at each hospital, and many more. Here, in the main coverage window, we see the consequences of real-time activity as measured against historic data in a color-coded map. This visual display offers situational awareness of coverage levels throughout the operations center, with the map's coloring indicating whether coverage is excellent, good, acceptable, and so forth. When coverage has diminished to a level where minimum standards are no longer being met, LiveMUM will offer a move-up solution. The baseline coverage settings for the initial LiveMUM implementation are closely aligned with the QAS's service delivery model. Calculations are performed statewide and do not force ambulances to stay within OPSEN or LASN boundaries. The application will endeavor to protect sensitive, remote areas in order to mitigate against longer response times. By offering users standardized recommendations based on data and QAS expertise, users will be free to focus on higher duties. A critical element of LiveMUM's implementation is the feedback given by end users. Here, in the recommendation window, LiveMUM will present two side-by-side maps. On the left, we see the current coverage situations. There are large gaps around Gympie in the north and Birwa to the south. The map on the right displays what the new coverage situation would be if a user committed the recommended move-ups. It is important to note that users can input and select alternative move-ups to test the impact of those moves. This is an effective way to validate or challenge LiveMUM's calculations. In addition, users can offer comments in the notes window that help explain why they agreed or disagreed with LiveMUM. Now that we have given some big picture information about LiveMUM, we're going to discuss the features and functionality that this tool uses to calculate coverage. One of the main drivers of coverage levels is, of course, the location of ambulances. An ambulance's location dictates which areas they can respond to within certain travel times. To build LiveMUM, we first calculate how many stations are within a certain travel time distance of each geographic area, and then assign that station number as the coverage depth. To further illustrate the concept of station depth, we can look at an example here from the Sunshine Coast. From the main coverage map, users can click on various elements of the main coverage window. When we click on each response zone, we can see what the depth settings are. Here, in this zone, we can see that Britannia, Kawana, and Bundoora can all cover this area. That creates a depth count of 3. We can also see that the time target used to create this station depth was 15.5 minutes. What this effectively means for coverage within LiveMUM is that so long as an ambulance from Bundoora, Britannia, or Kawana is available, that this particular area is considered covered. From LiveMUM's calculations, there are no other stations that could respond within 15.5 minutes to this zone. Another example can be seen here near Gympie. Gympie is quite an isolated area within the Sunshine Coast. There are not many stations nearby. Based on the 15.5-minute time target used here, only Gympie Station can respond to any of these zones. Effectively, this is a must-cover area. It is a station depth of 1. Continuing our discussion of depths, It is important to note that each travel time objective is based on whether the area is urban or rural and differs by each LASN. Looking at those classifications, travel time targets were then assigned based on the average response times to Code 1 and Code 2 calls. The purpose of this is to help ensure that LiveMUM is aligned with the current QAS performance and is configured to identify when ambulances are not within an acceptable travel time of critical areas. In addition to calculating the number of stations that can cover each area within a realistic time target, LiveMUM also considers what type of activity each ambulance is involved in. The length of time that an incident has taken historically is helpful for LiveMUM to consider the next time an ambulance is assigned to that same incident type in real time. It gives the application an estimation of how long it might be before that particular ambulance is going to be available again. If an ambulance has just been dispatched on a priority medical emergency and needs to perform a hospital transport, they can be unavailable for over an hour. However, if another ambulance is about to offload a patient at hospital after waiting for several minutes, then they may be available again shortly. In order to be very efficient about which areas require coverage, LiveMUM assigns an estimated time back value to each ambulance. If the nearby estimated time backs are quite high, LiveMUM may consider performing a move-up. However, if an ambulance is expected to be available within a short time, it would not make sense to drive another ambulance from several minutes away to come and cover. In order to use the most precise estimated time back values possible, we have calculated a unique estimated time back value for every combination of ambulance type, of status, incident type, ambulance location, and hospital destination and status. As an example, an acute stretcher resource who is transporting a patient to Logan Hospital will have a very different estimated time back than a Bravo unit located on the Gold Coast who is on scene of an incident and is not expected to transport. In addition to considering the location of ambulances and the amount of time they will be unavailable for, LiveMUM also considers the incident volume of an uncovered area before offering a move-up. For example, let's review the coverage gap created here around Caloundra and Birwa. This area is a depth of 2, and there are no ambulances at either station. Before recommending a move-up, LiveMUM assesses what time of day of week, and season it is to determine the likelihood of a new call occurring in the zone. The estimated time back of the ambulance from Caloundra in this example is 65 minutes, and it's Friday night at 5 p.m. In this scenario then, the likelihood of a new call occurring here within the next 65 minutes on a Friday night at 5 p.m. is 92.15%. That's high enough to justify a move-up. Conversely, this area around Monto is serviced by only one station. This ambulance is going to be unavailable for 90 minutes. It's a Saturday morning. The resulting call volume is only 5.68%, which is below the 15% threshold. LiveMUM will color this area brown and will not recommend a move-up. Call volume is an important mechanism for LiveMUM to be able to recommend units who are going to perform a move-up and contribute to the system. This will help ensure that they are closer to calls for service that might occur. In addition to considering real-time ambulance locations, estimating the amount of time it will be before ambulances are available again, as well as the likelihood of whether a new incident is going to occur, LiveMUM is also considering the start and end time of each crew's shift. In order to help support the movement of crews around the beginning and end of their shift times, LiveMUM will take the timestamp that a crew logs in and will assume a 12-hour shift in Southeast Queensland and a 10-hour shift in the regional operations center areas. Using this assumption about end of shift time, LiveMUM will apply a couple of rules. These rules help ensure that units who are towards the end of their shifts are not recommended for long move-ups. For example, when a resource is within 30 minutes of the end of their shift, they will only be permitted to move up 10 minutes away. 15 minutes before the end of their shift, they will no longer be eligible to move up at all. In addition, if a new ambulance is expected to log on within 15 minutes of a station which has a current coverage gap, LiveMUM will not recommend an immediate move up to fill that gap. Instead, it will wait for that next shift to begin. Now that we have discussed the core coverage elements that form LiveMUM's calculations, it is also helpful to discuss how other data comes into play. For vehicles which have an MDT on board, LiveMUM is able to track the GPS coordinates that those MDTs emit in order to update the ambulance's real-time location within LiveMUM. With each new set of coordinates, LiveMUM will evaluate which station that ambulance is now closest to. Depending on that ambulance's status, LiveMUM may snap it to a nearby station, providing coverage from that area. An important extension of this use of AVL and GPS coordinates is a feature within LiveMUM called redirection. When a user commits a recommended move up and the ambulance needs to travel to the destination station, the coverage around that destination station will immediately show as resolved. However, LiveMUM will continue monitoring the vehicle's real-time location as it travels to the destination station in order to update coverage if needed. For example, when I commit these recommendations, LiveMUM will show the coverage gap is resolved right away. However, it will also note in the back-end calculations that in fact those ambulances are still traveling to the stations provided. While that ambulance is en route to the coverage areas, LiveMUM will continuously monitor their real-time locations. Should coverage change, LiveMUM will immediately advise whether that unit can be redirected back to their original home location, or if they can be used for coverage elsewhere. In addition to day-to-day coverage issues, LiveMUM also offers specialty features that are meant to support specific circumstances. For example, traffic conditions can greatly impact which move-ups are being recommended. If a unit, for instance, would normally be able to travel across a particular bridge or highway during the middle of the day, during the afternoon and commuter rush hour, that may not be so realistic. LiveMUM currently incorporates historic traffic patterns to help make this calculation, and it also has the capacity to incorporate live traffic. LiveMUM is also built with the conditions feature. The conditions feature will deploy a new set of configurations that help support a particular event. For instance, schoolies is a condition that has been built into LiveMUM. Users can automatically select this condition to be toggled on or off. When ambulance availability is reduced statewide, the low unit availability condition will automatically be turned on. This will make other units who are typically not eligible for a move up now eligible to move. Finally, the LiveMUM Brake Manager component will help identify when different crews are eligible for brakes. The Brake Manager component is currently configured to support QAS operational practices. This includes such rules as only taking brakes at a unit's assigned home station. When a unit becomes eligible for a brake, they will appear here in the brake pending list. If that meal break is interrupted, they will populate under the brake interrupted screen. Brake Manager will also identify a few important pieces of information, including the likelihood of whether this brake will be interrupted. Regardless of whether the brake is likely to be successful, anytime an available unit is at their home station and within their brake window, the Brake Manager tool will provide a notification and a recommendation that the brake should be initiated. Brake Manager also visually highlights which brakes are actively being given currently. We will now move to an overview of the main components of the LiveMUM windows. Users will log into LiveMUM using their corporate username and password credentials. Each EMD and supervisor can select either a single or multiple dispatch boards to log in with. If you would like to change your selection after you have logged in, simply come up to the menu button and click Agency Selection. Agency within LiveMUM refers to each dispatch board. Each user will have the opportunity to select a board as either active or view only. The View Only button will simply enable the coverage map to be displayed. Users will not see move-up recommendations associated with that area. If we wanted to turn on the Metro South board, for example, we would now see the coverage for Metro South. If I wanted to see both coverage and move-up recommendations for the Bayside board, I would choose that board from the active column. This will reorient my map view and also add those units to my unit tracking window. The coverage score for Bayside will also be presented on the main coverage window. From the View button, users can toggle on different visual elements. They can see the main streets that have been built into the application. They can also select different labels for various locations, including hospitals, first responders, and airports. When a recommendation is actually pending, users will be notified through a variety of mechanisms. This includes a pop-up window, flashing of the Capability tab, as well as the taskbar pop-up. In the future, this notification will occur directly as a CAD alert. To open the recommendation details, the user can interact with any of the notifications that were presented to them in order to automatically open the screen. Here, users can test the consequence of a move-up of their own choice. They can select the unit, the station, and click on those recommended solutions to test their impact. In order to log a comment about the move-up, users can type text into this box and then click Log. In order to actually commit the recommendation, simply navigate to the Commit button and confirm that this move is being approved. LiveMUM will automatically close the recommendation window and return to the main coverage map. This concludes the introductory training for the LiveMUM application being deployed for the Queensland Ambulance Service. If you have additional questions, please feel free to email the address listed here. Thank you for your time.